Chemical wastewater containing phosphates is environmentally hazardous. Most facilities use one of the two phosphate removal techniques: chemical removal using various reagents and sorption. Purification during the production process is inefficient. It must be performed in several stages and takes a long time. For instance, decontamination in reactors takes as long as 30 minutes. We have researched the process of removing phosphates from wastewater by the AVS Vortex Layer Magnetic Mill. We studied the influence of treatment duration and pH of the medium on the degree of decontamination, determined the optimal ratio of reaction components, processing rate of the mill, and the influencing factors, as well as optimal process conditions. The substance used for the research was industrial wastewater with 4,500 mg per liter phosphate concentration, pH of 4.0, 10% lime milk processed for 1 to 3 seconds in the mill, reagent consumption of 70 to 120% of stoichiometric, pH of the wastewater during processing in the range of 4.0 to 12.0. The content of phosphate in wastewater was determined by phosphate photocolorimetric method. Test results are presented in tables below. The research in industrial conditions was performed using a pilot unit in which wastewater from the production process was first supplied to equalizing reactor, while prepared lime milk was supplied to a consumption tank. The research into decontamination of wastewater in the AVS has shown that magnetic mill is more efficient comparing to equipment currently used for this purpose. Converting phosphates into water-insoluble compounds occurs in one stage. The duration of treatment is 1 to 3 seconds. The reaction used is lime, with 5 to 10% excess calcium oxide of the theoretically required amount. Using the AVS for wastewater decontamination allows to reduce the consumption of reagents and power, decreases equipment footprint, and improves the quality of the decontamination process. The process in the AVS mill occurs in one stage. Therefore, equalized wastewater is pumped directly into the AVS together with lime milk from the consumption tank. Both components are intensively mixed, dispersed, and subjected to electromagnetic field in the AVS, then pumped to settling tanks for clarification. The flow rate of wastewater and lime milk is monitored by flow meters. Acidity of the wastewater is controlled by pH meters. The research allowed to identify optimal conditions and efficiency of wastewater purification.